Number 3. What do we get?
Sorry, I'm getting there. I got. Okay, that's the one I had a question on.
Okay.
I know the equation, so if you already have a mean, so like the ones below it I got, but not number 3 because I didn't know how to get the mean.
You don't need the mean for this.
I don't need the mean for that one.
No, so the formula for margin of error is Z times O divided by the square root of N. So it's like Z times, in parentheses, O divided by the square root of N. And in the book, I believe the most popular Z-scores.
1.96.
Yeah, so for 90%, it's 1.645 because it's a 90% confidence interval.
So how did you find out that Z-score?
You
Put the 90 in the applet.
Yeah.
So I just put 90 into the applet?
Yeah, I
0.9.
Yeah, it's 0.9 into the area.
Okay.
Okay, wait.
Is it? Hold on.
I just did that and I got 0.126.
Well, you want just the middle highlighted.
Oh,
not the edges.
Okay.
Where do you get the applet from here?
There's a link.
Right
Okay,
at the top of the quiz.
0.1164 or 1.645.
Yeah, that's what you use. And
the answer is what?
No, that was the Z-score. The Z-score is 1.645.
And then you're timesing that by the standard deviation, right?
Well, like in parentheses, it's going to be standard deviation over the square root of N.
Yeah.
And so it'd be 50 divided by like 5, which is 10 times 1.645. So you'd get 16.45.
Yeah, that's what I got, but I didn't think that was right. It's like, there's no way.
Let me.
I cannot find the applet.
Sorry?
I can't find the applet.
So go to the very. Oh, you know what?
Well, right above question 3.
Yeah, right above question 3.
No.
Oh my goodness.
So Courtney.
Now you have to start all over because I couldn't even listen because I was trying to find the stupid applet.
No. So you can skip this real quick. If you go to lesson 10 in the book, right around the middle. Let me share my screen. Okay. Y'all see my screen?
Yeah.
So this is in lesson 10, right? So you go down to like the middle, and it'll give you the Z-score of these confidence intervals, the 90, 95, and 99. And these are the most common ones that we're going to be using.
Okay.
I wrote those in my notes.
Yeah, and so for number 3, where it says 90%, you can just go here to lesson 10, and you got it right there. But in the applet, like James said, you can just put the area, highlight the middle, and there's your Z-score.
Nice.
And then what do you do with the Z-score?
So the formula for margin of error is M equals Z times, in parentheses, O divided by the square root of N. So using the actual terminology, it would be the Z-score times standard deviation over the square root of the population. So in this case, your confidence interval, your Z is 1.645. So you're going to multiply that by in parentheses 50 divided by the square root of n, which is 5. So 50 divided by 5 is 10. And you multiply that by 1.645. So you just move the decimal 1 to the right, and you
Right.
15.45.
That was pretty easy.
Yeah. Yeah, so for that one, you don't need like Q or X. So you're fine.
Okay. Got it.
Okay, number 4.
Got B.
Statements is true. Which did y'all get?
B.
B.
It is B, the second one.
Yep.
Yeah. So for this one, just remember that X bar is the sample mean, and mu is the population mean, and the population is always greater than the sample. So you get the sample from the population. And that's why X bar is a point estimator of U.
Oh, that's a good
Okay.
explanation.
Say that explanation one more time so I can write that down.
Okay, so
X bar is
X bar,
sample mean.
yeah, X bar is the point estimator of mu because X bar is the sample mean and mu is the population mean. And the population is always greater than the sample. That's where you get the sample from. And that's why X bar is the point estimator of mu.
That's a very, very well stated.
So the population is always greater than the sample
Yes.
mean?
Yeah. Yeah.
Okay. That is a really good explanation. Thank you.
I guess saying always is a bad way of saying it because you would get X bar, you would get a sample from your population. But the sample mean could be greater than the population mean if they were to take the people from
Yeah,
the population
depending
that
on
had the greatest numbers.
Yeah.
That would be, since you're taking a smaller amount with greater numbers, it could be bigger than the population, but it doesn't happen too often. The greatest way of saying it is like you always take a sample from whatever you got.
Mm-hmm.
You can't take more than what you have, and that's what X bar is. It's less than that. It's kind of hard to say. It's a weird way of saying it.
Yeah, X bar's guessing,
Yeah.
estimating on the whole.
X bar is like a portion. There you go. X bar is the portion. Mu is the whole. Best way of saying it.
Yeah.
Okay, number 5. What is the point estimate for the true GMAT? Anybody get that?
I think I might be wrong, but I got 8.219.
I got 526.
Yeah, it's just X bar. You're making
Oh,
it
it's just X bar?
complicated for me.
Oh, shoot.
Oh,
Okay.
Yeah,
Oh, and that's the definition you just told us. Point
Yeah.
estimate is X bar.
it's the point estimate. So yeah. Okay. Well,
Man, I YouTubed that on Khan Academy, and that's what they helped me work out.
Khan Academy is a great site. I use it for biology. That's so much math. All right, number 6.
What bio class are you in?
I'm in Bio 180.
Okay.
I've always had to drop it because of events going on every semester. So this is like math. Several times taking it. Number 6 is just like number 3. We're finding what is the margin of error for the 95% confidence interval for the true GMAT score. So you go to less than 10 again. The 95% confidence interval is 1.960. So you use that as your z-score, and you multiply that by the O divided by the square root of n. So it'd be 1.96 times, in parentheses, 113 divided by the square root of 64, which is 8. Yeah, what did everybody get for number 6?
Sorry,
Put
I had the
20
wrong answer, so I'm working it out again.
I don't know. What is the right answer? I don't know if I have the wrong or right answer. I have 28.25.
I got 27.685.
That's what I have is 27.685.
James, you're correct. Ginny Ann, you might have just done something out of order.
That's what I'm wondering here.
Remember, you have to find the square root of 64, which is 8. And then you divide 113 by 8. That'll give you some funky number.
27.685. That's what I got.
Yeah, so once you divide 113 by 8, you multiply that by the 1.96. And that'll get you the 27.685.
I better write the answer down. 27.65.
685.
685. So you have 3 decimal points.
Yes, ma'am.
Okay.
So for number 7 and 8, all you do is subtract number 6 from 5 or add number 6 to 5. So for number 7, it's the lower limit. You subtract 27.685 from 526.
See, I knew that that's how you got that, but I had the wrong number, so all my numbers were
Me
wrong.
too. I knew that's how you got it, but I was using the answer I got previously to do it.
No, but I mean, you guys know how to do it, so just use 27.685 as your margin of error. And so for number 7, you should get 498.
Wait, isn't it going to be half of the margin of error to get the lower limits?
No,
No.
I think that is for, I want to say that's for a single-tailed test. It's somewhere in the reading.
Okay.
At a certain time, you do
You do half. Okay.
you have to do some more math with.
So you take 526.
For number 7, you subtract 27.685 from 526. So you end up with 498.315.
498.315. Okay.
And for number 8, you add it. You get 553.685.
I'm glad we did this because since I did that first one wrong, I did
Yeah.
all the equations right, but I have all the answers wrong because I put in the wrong numbers.
Yep.
Okay, number 9. What would happen to the width of the confidence interval if Gina increased the sample size?
I put decrease. I don't know if that's right or not.
That's correct.
Decrease. Yeah, that's what I got.
Yeah. So just think about it like, just think of like the width as being the amount of difference that you can have. So if you have like a sample size of 5, you can have 5 totally different numbers. If you have like a sample size of like 1,000, it doesn't matter what numbers you have in there. Your average is gonna be pretty darn small. So everything's gonna be pretty close. So that's how I think of it. The greater the sample size, the smaller the parabola hump, whatever you want to call it.
Got it.
Okay, number 10, what would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval?
I put increase.
That is correct.
Yep.
I have no idea how to explain that one, so good job.
I just read it in the lesson.
Yeah,
So, yeah.
Yeah.
If it increases, it increases.
yeah.
Yeah, that's one of those that I made a note on.
I'm sorry?
That's one I made a note on. If sample size increases,
Yeah.
it'll make sense later, right?
Yeah. Number 11. What sample size do they need? So the formula for that is,
Yeah, I didn't get this one.
I don't know if I copied the formula right, but yeah. So it's Z times O divided by M squared.
So where do you get M? That's where I was kind of,
M is the margin of error. So you first have to calculate the margin of error. So
okay.
which one are we on again?
And I did that wrong because I was halving it.
Yeah. So you use the, what you call it,
95%,
confidence interval, which is
1.960.
yeah, and then multiply that by the standard deviation, or you multiply the standard deviation by the square root. Oh, flip. They already. I'm sorry. They already give you the margin of error. Sorry. They already
It's
give you
50, right?
It's 50. Yeah. I'm overthinking it. Yeah. Margin of error is 50. So the formula for the n, I already went over it. You get 50. So you have to do the z, which is 1.960 times o, which is 400. And then you divide that by 50. Remember, you have to multiply first, and then you divide. And once you get that answer, you square it.
Oh, that's right. I forgot the square.
Times 400. So you're doing, so 1.964 times 400, so 784, and then divide it by 50?
Yeah.
So 15, divided by 50. And then, so you are getting 1568, and then you square that.
Yeah.
So 3.95
Good Lord, no. What,
or 3.60 or 3.960, I mean.
no. What
No,
have you?
you're getting a
You took
square
the square
root.
root or something.
Yeah.
You gotta actually square it.
Oh,
Yeah, no, it's squared, so you multiply by itself.
by
Yeah.
itself.
Yeah.
Okay. 245.862.
Yeah.
That's what I got.
For number 11,
Around.
you round it to the whole number. It would be 246. You got the right answer.
Oh,
Got
whole
around.
number.
So just
Yeah.
246. I don't have to do it. Oh, it says round to the nearest whole number. That's why.
Because it's a sample size. You can't cut a person in half.
All right. Number 12, right? What is the lower limit of this 95% confidence interval? Mercy. What do you guys think? So first one, you'd have to, I think, find the margin of error. I think.
You have to find the.
Yeah, because you're not given the margin of error here. And that'd be pretty easy to find. You're given the U, you're given the mean, you're given the standard deviation, you're given n. So remember, you don't need mean for this, for finding margin of error.
Okay. This is the one I keep getting confused on. Well, not
Yeah,
so
remember,
it's like
margin of
number
error.
3 that we did, right?
I'm sorry?
Is it similar to like number 3 that we did?
No, it's similar to numbers 7 and 8.
7 and 8.
So you have to find the point estimate, and that's going to be 111,000.
They give that to you.
Yeah. So see how I mean? Like X bar can be greater than mu.
Oh, yeah.
It just means they just took a portion of the population that had the biggest scores, and that's how they got a higher mean. Yeah, you find the margin of error, and then for number 12, you subtract it. And you
So you should
should,
try. I think I have this one too. Boy, I just got that in my brain. Well, maybe not. What is the answer?
for number 12, it's going to be 99,002. So it's
I did it right.
99002.
So walk me through that one. I get how you get the lower limit, but how did you get, what are you subtracting that from?
So remember, you have to find the margin of error.
Okay.
And for the margin of error, if you see U or X, just ignore it. You don't need it for this part.
Okay.
The only thing you need is the Z-score, the standard deviation, and the population. Bless you.
Somewhere in the book, it gave a formula for the margin of error as 2 times.
Oh, good heavens, ignore that. No. That's what confused me, and it messed me up. Ignore it. No.
Wait, that's how I got the answer.
That's how you got it? Mercy.
Because I looked at that and was like, okay, plug the numbers in.
Oh, my Lanza.
But maybe that's where I halved it too. That's why I'm confused, because I halved it. I don't know. I'll work it out and see what I did. But I got the right answer.
Hey,
What'd you get? I don't think I got that.
So then, I think I got the margin of error. Now am I subtracting it from X bar?
yeah.
Okay.
Now, if you get it wrong, consult me.
I got it wrong.
Okay,
What
so,
do you guys get for margin of error?
okay, so here is how I got my, mercy, where is it?
Well, now I can't even recreate how I got it. So
Screen share is freaking awesome. Okay, can you see this part right here?
wait.
So 196.
Yeah. This is how I got my standard deviation.
See, that's what I did.
Like this is my standard deviation. It's 1.96 times in the parentheses the 36,730 divided by the square root of 36, which is 6.
6.
And that's how I got 11,998.
Oh, I didn't. Okay, so I did what was in the parentheses, but then I didn't go back and multiply it by the Z-score. I didn't multiply it by 1960.
Yeah, so you have to multiply the O divided by square root of n times the z-score. And so once you take this and you subtract, I know. No, you get the point. You subtract the 11,998 from the 111,000, and you should get, after rounding to the nearest whole number, you should get 99,002.
Two.
Okay, I see how you guys got that.
Okay. So for number 13, add that 11,000 to the 111,000. You get 122,998.
Yep.
What'd you guys get for it?
122,998.
I was just writing all the notes down so I could remember how to do it.
Nope, we're good.
Alrighty. 112,998.
No, sorry, 122,998.
122.
Yep, 122,998.
Got it. Okay, I think I got all these notes down.
Awesome. 13, there are 3 requirements that need to be checked in computer. The answer is D, all of them,
The above.
all of the above.
Yep.
Yep.
I like that one.
Yeah, right?
That was an easy one.
It's okay, you won't see those on the exam. It's okay.
No, darn it.
Submit it and you should get 100.
I got 100.
Yep.
Got it. So I'll submit the URL.
Yep. I'll do the, which one's the one that writes like what we had problems with? No
With-
take.
I feel like Quizmaster and Note Taker do the same job.
You know,
Yeah.
To be honest.
you know what? I'll just say that we had trouble with margin of error. We cleared it up. That's what I'll put.
Okay, so just say you're the Note Taker.
Sure.
Okay.
Whatever.
You want me to be the quiz master and I'll write relearning stuff is hard.
Hey,
I like it.
And
I gotta go
James,
to
you
work.
can do attendance.
Yo, Friday.
See you Friday.
Well,
Okay.
is the
Huh?
is the next quiz due Friday or is it
I hope so.
due?
She changed that last week because, I sent her an email and I wrote somewhere and she said, oh, let me change that. So
Oh,
it was supposed to not be